Okay, we're going to work with another series parallel circuit. See, we have a 14 volt source. Resistor R1 in this case is 1.5 kilo ohms, and it's tied across the source. That would actually be in parallel to the source. R2 is the 1K, R3 is the 1.2K. Those two are in series with each other. If we look here, any current that comes out of my battery is going to go here, and it's going to have two directions it can go. One direction is through R1, one direction is through R2 and R3. Therefore, R1 will have exactly the same voltage, because it's in parallel, as the battery. I'm going to switch pins here. There we go. That means I can go ahead and find my current for R1. So I'll call this I1, current 1. That'll be 14 volts divided by 1.5 kilo ohms. So I'll take my calculator. I'll do 14 volts divided by 1.5. I'll get milliamps out then, which is 9.33 milliamps. Now this current goes through R2 and R3 are in series, so if I want to find that current, and I'll call it current 2,3, that will be, it's 14 volts from here to here across those two resistors, 14 volts, 1K and 1.2 in series, 2.2 kilo ohms. So I would have 6.36 milliamps. Those are in series, so it will go through both. Now I can go find the voltage across R2. That would be 6.36 milliamps times 1 kilo ohm. So that'd be 6.36 volts. And across R3, V3, which is across R3, is my 6.36 milliamps times 1.2 kilo ohms. So I'm going to end up with 7.64 volts across it. Double check, those do add up to 14 volts between them. This means my current coming out of the battery should be 9.33 milliamps. It's going to go through R1, plus the 6.36 that goes through both R2 and R3. So I'd end up with 15.69 milliamps out. Now I can go through and double check this. So if I wanted to find the total resistance, R2 and 3 are in series, so I can replace those with a single resistor. So I'll rewrite my circuit right here. Here's my 1.5 kilo ohm. Here's my R2, 3. We already know they're in series, so it's 1K plus 1.2, so I get 2.2 kilo ohms. So I have two resistors in parallel. So the total resistance, I'll just call R1, 2, 3, because its combination is 1 over 1.5 kilo ohms plus 1 over 2.2 kilo ohms. And if I do 1.5 inverted, 2.2 inverted, and add those, I'll get 1.12. And to get the actual resistance, I do 1 over that, 0.8919 kilo ohms, or I'm going to just round that all off to 892 ohms. That does mean I could write my entire circuit as 14 volts, (892 ohms). The current out of the battery is 14 volts, just using Ohm's law, over 892 ohms. 14 over 892, 0.0157. I'll multiply by 1,000 to get milliamps, and I have 15.695. It'd round off to 15.70 milliamps. So my current through the entire circuit is exactly equal to the current I found when I found the individual ones. I mean, I had that one little rounding spot in the end. Okay, now I can go through and do power. 14 times 15.69. So I have 219.66 milliwatts into the circuit. 14 times 9.33, 130.62 milliwatts. 6.36, 6.36. It's 40.45 milliwatts. 48.59 milliwatts. So 48.59 plus 40.45 plus 130.62 is 219.66 milliwatts. All my power in is equal to my power out in all these resistor circuits. So now I've done the theory for this series parallel, and I want to construct it. So if I want to construct it on the board, I'm going to need 14 volts from my source. I'll have 1.5 kilo ohms going all the way from positive to negative of my source. So if I want to here, I'll bring my board over and build it on here. 1.5 kilo ohms really just goes all the way from the positive all the way down to my ground. And then I have R2's 1K and R3's 1.2K in series. So I take my 1K and take it from my source voltage. I'll bring it down here. And then I'll take from my source all the way to ground. Those two are in series. This one is in parallel with that series combination, just like our initial schematic. Now I can turn this on. As a reminder, I would do all these measurements for voltage and currents with my bench meters if it weren't for the fact that I could just put this in here so you can see it. No reason. This is not as handheld or never as good as the bench ones, so you might as well use those. I need to turn this up to 14 volts. So I'll go with 14.13. Obviously, I think if I measure my voltage across my resistor, I had to get 14.13. Voltage across R1, I should say. R2, I will get 6.42 volts. I calculated 6.36, so darn close. 7.71 volts. And we said R3 ought to be about 7.64. So again, close. If I want to measure current, then I'll need to set this for current. Pull my source, measure current to this for my source current. Each individual resistor I'll disconnect and put the current ammeter right in here. Likewise for these two resistors. The last thing I want to do is I'm actually going to disconnect my power here. That way I'm not accidentally excuse me, measuring it. I'm going to check my total resistance. So we'd calculated total resistance and got 892 ohms. So let's see what we get now if I measure across this entire thing. 876 ohms. Note it says 0.876 kilo ohms, but very close. Alright, so we built it on the breadboard. We did our measurements. Let's go now and try to do it on the terminal strip. So I'll bring that. So when I build this, I'll put my sheet out here where we can see our schematic. I'm supposed to have 1.5 kilo ohm. And I'll just connect that on. I'll spread it out because these two need to be in series. In fact, maybe I want to do them first. You can do it either way. So let's try this. Let's take those two. Okay, so this would be R3. Now I'm going to take R2. So I've got R2 in series with R3. It's not wanting to stay there. Okay, I may have to. I tried to slip these in and just tighten them all down at once, but let's go ahead and tighten the center one. There we go. And now this one. So R1 and R2. I'm sorry, R2 and R3. Now I'll measure right here. Or measure. Put my resistor over here. And that's R1. So R1 is going to be in parallel with that series combination. In fact, before I connect power, let's go ahead and check my resistance. So I have my ohm meter here, ready to do resistance. And let's see, how can I get it so you can read it, see it? How about there? Just not cooperating with me, is it? All right. So I'll place it in there. 0.877 kiloohms, or 877 ohms. Maybe a little higher than my breadboard because I might have a little higher internal resistance here, but not much. Okay, now I'm going to connect to my power supply and connect power to my breadboard. And once again, I'd probably use the separate power supply for this in lab, but that's harder for you to see than the board. So I will bring this over and we will put positive here. We're putting negative on this side, or ground. We don't really have a negative voltage, we just have positive and ground. And turn this on. Nothing's hot. I'm going to check my voltage for my source and record my actual voltage. And I'm at, it's not wanting to get, so let's get down here. So we'll just measure from source to source. So I'm at 14.12 volts. And then I'm going to go in, and I'm going to measure my individual resistor voltage there. R1, that was my R1, this is R2, 6.42 volts. R3, 7.71 volts. When it's time to measure current, I would move this over, switch to current, and then I'd want to go in and I could disconnect here and measure. Again, I still have working handheld ammeter, but I have one on a bench one I could grab. To get in this first resistor, what I would want to do is I would actually need to disconnect it so it is separate, but I need my source voltage still to be connected to everything, so I'm only getting through this. If I tried to connect here, it'd just give me the source, so I need to come over here and measure. That would give me the current through this resistor. Then I'd replace that resistor. To do this resistor, I would just disconnect this one and measure. Probably just touching would be enough, but I could clip if I needed. That should give me that. These two wires touching doesn't matter, it's already connected here. And then finally, I could do my other one. It might be tempting to disconnect in the middle, and you can certainly do that. It's just because you have two things connected at the same terminal. I might disconnect over here. And I would then connect this and measure that current. So I can measure all those currents. They should line up with I got my theory. Always want to go back and double check that. And I should be good. So now we know how to build a couple of different series parallel circuits, both breadboard and on the terminal strip, and we know how to do the analysis, which should lead us to doing any kind of series parallel circuit, even larger ones. We could easily do 4 or 5 or 6 resistors now if we wanted to.